Good morning. PaaS Virtual Summit 2020, deploying big data clusters, 8 a.m. What were they thinking, scheduling me at 8 a.m. in the morning on the last day? But, well, it's just 2 p.m. here, so I think we're all good. Let's get started. First of all, you have seen this slide, but it makes it nonetheless very important. Please explore everything PaaS has to offer, including the PaaS Pro membership, SQL Saturdays, how you can become a volunteer, how you can get involved in local user groups if you don't do that already. Also, there's two things that are kind of missing from that slide. We currently do have an election going on. There's 3 open seats for the passport or 3 seats that are up for election. So please make sure to make your vote count. And also go ahead and visit the exhibition hall, visit the sponsors that also help making this PaaS Summit happen. Just use the breaks in between. My name is Ben Weisman. My pronouns are he, him. I'm a data passionist from Nuremberg, Germany. If you have been to a couple of my other sessions this week, you will have already noticed I own more than one pair of glasses. I'm a Microsoft Data Platform MVP. I'm an author for Apres and Pluralsight. And with that, we can almost get going. Let me take the opportunity to say thank you so much, Bob Pusateri, who's going to help me moderating this session, and also Eric from PaaS HQ, where it is right now, I think 5:02 in the morning. I realized he is very precise about timings at this time of day. So what are we going to do? We're going to have a very quick refresher. I assume many of you have already been working or at least looking at big data clusters, potentially following the learning pathway that is going on here at this year's PaaS Summit. Still, I just want to make sure that we're all kind of on the same page on what big data clusters do and their foundation. Then we're going to take a look at where can I deploy big data clusters? What do I need tool-wise? What are my necessary steps? And then it's going to be all demos and also, of course, Q&A. Whenever you got questions, feel free to drop them into the Q&A board right next to this video. Keep in mind, there is a slight delay between me talking and you hearing me. So if you have a question and don't answer it immediately, that may be because of exactly that delay, and Bob will figure out a good time to actually ask those questions, and we will get to them towards the end at the very latest. If not, my contact details will again be on the very last slide, so we will make sure to get all your questions covered. So with that, a little refresher. Let me just remove myself here so you can actually see something. From virtualization to containers. If you've been to the architecture session from Buck Woody or also some of the other sessions, you've probably seen that. Still, just a little reminder. Big data clusters, they run on containers. So containers, not the same thing like VMs, because a container is way more lightweight. A container will share the host's operating system. A container is running based on images. So that means instead of having, like, for example, 3 different full-grown servers on a Windows hypervisor like Hyper-V or VMware, the big difference will be you don't have 3 disks that you need to maintain. You don't have 3 different machines that you need to supply with updates. And you also don't have to have all that disk space wasted. The thing about containers is they mainly run on Linux. There's Windows containers, but Windows containers got a couple of downsides. So interesting fun fact about big data clusters only run on Linux because they run based on containers and they run on Linux-based containers. Interesting from the perspective that if I had told you a couple of years back that I will be deploying SQL Server on Linux, you would have told me it's not possible. And now we have, for the first time ever, a feature set with it, which is big data clusters that only runs on Linux. Interesting. Containers have a big disadvantage. They don't talk to each other very well. And this is where container orchestration comes in. And we do that in big data clusters mostly through a tool called Kubernetes. There's other ways of doing it, but Kubernetes is one of the most popular container orchestrators out there. And the idea of Kubernetes is you have a bunch of so-called nodes, which can be a virtual machine or a physical machine, depending also on where you're running this. And these nodes run so-called pods. A pod is a combination, a group of containers. And the orchestration master in this cluster, this will make sure that you got your pods spread across all of your nodes and therefore getting best of performance. And if one of those nodes goes down, the pod will go up immediately again. And pods, well, if a pod dies, it goes away and will never come back in the same way it was. So in Kubernetes, we separate between storage and compute. And that's why we would usually have some kind of external storage mounted to our cluster. So if one pod goes down on one node and comes up on another node, either because of that node goes down or because of an upgrade or for whichever reason, we will still have access to the very same data. So we could have a SQL server, for example, moving all the way around across all these nodes, and it would still always be reachable and available using the same address, using the same port, and so providing the very same data to you. And in such a Kubernetes cluster, what we will be doing is we're going to be deploying a big data cluster. A big data cluster consists of, well, 15-ish pods at least, and even way more containers because all these pods consist of multiple containers. And that is because, well, we have the BDC controller, which is basically the first thing to be deployed, which will take care of the ongoing deployment. We got a couple of shared services like a metrics database, the Grafana dashboard that I'm sure you've seen over the course of this week, the Kibana dashboard that will provide us log files across all the board for all our cluster. We got the SQL Server master instance, which is its own pod. We got the compute pool, which may be one SQL Server pod, or it might be multiple pods, depending on how you size it. We got the data pool, our hot cache, where we can distribute data across multiple SQL servers. Well, all these SQL servers, all these instances, all these little shapes here, they are their own pods. And that looks kind of overwhelming because if you think, well, all these components, they need to talk to each other and you need to deploy them and you need to maintain them. But Microsoft is making this super easy for us because in the end, this is all running through one streamlined process. And that's what we're going to take a look at in the next step. The first question that you will need to answer for yourself, or you maybe even have an answer to that. Am I going to deploy my BDC in the cloud, or am I going to deploy my BDC on premises? In the cloud, you could use something like Azure Kubernetes Services, OpenShift on Azure, or just a kubeadm on an Ubuntu VM. And on-prem, you could use Ubuntu, kubeadm on Ubuntu again, or you could use something like OpenShift. There's a bunch of other targets that you could use, but those are the most popular ones, I would say. So, hey, Bob, you've deployed big data clusters before, right?
Indeed, I have.
So what was your target? What did you choose?
I was deploying to Azure Kubernetes Service. So I did a pure cloud deployment.
Cool. Is there a specific reason for that?
Ease. I do not have the hardware here to run it on premises, and I'm most familiar with Azure. So started off in
Excellent.
AKS.
And expected answers. So that's one thing that you need to consider. Azure Kubernetes Services is a Kubernetes service in Azure. Well, it's in the name, so boom. The idea is you don't take care, like with any service that you just deploy straight to the cloud. You don't care about something like deploying VMs and installing components on them. No, you just deploy one single service and it will take care of everything. Still, you need to be aware, big data clusters are part of SQL Server, of the Box product. So you will be in charge of installing and maintaining your big data cluster. It's not like the same thing like, for example, Azure Synapse Analytics, where you get a full PaaS offering. You're still kind of in between. If you're getting a PaaS offering from the Kubernetes side, it's still more infrastructure as a service, and then you're deploying your application into that. So that's something that you need to consider. And while I was kind of expecting the answer you just gave, Bob, most implementations that I've seen so far actually cover scenarios where people cannot go to the cloud or are kind of in between in a hybrid approach and still want to get the advantage of having a data lake, for example, on-prem that they can still consume using Spark and SQL. And those are the beauties of BDC, I would say. Of course, we need a couple of tools to do that. There's a couple of official prerequisites. You need kubectl or kubectl to talk to your Kubernetes cluster. While you don't need Azure Data Studio, you need Azure Data Studio because unless you really want to do everything from the command line, but Azure Data Studio offers us a couple of nice wizards. It offers us a great experience, especially if you want to get started. And that comes back to the same reason. Bob, when you deployed your big data cluster, am I right in assuming that you were using the wizard in Azure Data Studio?
That is correct. Definitely generated a nice notebook with all the information you need.
How was that experience?
It was excellent. It's easy. Like I said, go through, answer a couple questions, generates a notebook. I've tweaked that notebook a little bit for my personal needs, but now when I want to deploy a BDC, I just run the notebook.
Well, now that you say that, I should have made this session a lightning talk, I guess, because it's so easy. But I will just come up with some more complex scenarios that people don't actually need, but just to fill the time, I guess. There's another tool that you're going to need, AZ Data, Azure Data, and AZ Data will be the tool that actually runs the deployment of a big data. It actually does more than just deploying a big data cluster. If you've heard of Azure Arc enabled data services, for example, those would be deployed through AZ Data as well. And if you deploy through Azure Data Studio will do nothing but call AZ Data in the background. So AZ Data is the actual tool you need. Still, Azure Data Studio just makes it a lot easier for us. And if you're going to deploy to the cloud, like for example, AKS, you will also need the Azure CLI to be able to actually communicate with the portal, unless you want to do everything through the portal. But yeah, generally don't do everything through the portal. It's so much easier and nicer if you just get everything scripted out. There's a couple of more tools that I would recommend to you. These are obviously Windows tools. So let's assume you want to debug a big data cluster. You end up with a file that has the extension .tar.gz, a tarball file. You could not open that using regular Windows zip, so you would need something like 7-zip. If you don't like 7-zip but prefer WinRAR, go for it. Once you extracted that archive, you're going to end up with a potentially big, or even huge log file. Notepad doesn't do with that. Notepad++ does. Once our big data cluster is deployed, our main entry point is the master instance. And the master instance is nothing but a regular SQL Server 2019 with maybe the exception that it is running on Linux. That might be the exception to the rule when speaking of a regular SQL Server. So command line utilities may not hurt. And if you're deploying towards Ubuntu, you may want to be able to secure shell into that. Everything we're going to see today is kind of platform independent. So if you're running everything off of Linux, for example, you obviously will not need Notepad++ and 7-zip or PuTTY because, well, you're already in your Linux machine. So this is just a set that I kind of recommend for the typical Windows user. And I still see that most of us SQL people are actually Windows users. And having that said, I also highly recommend to use a package manager. And I'm going to show you an example on how that could look like. I will provide you a PowerShell script that if you just run that, you will have all these tools installed. Because what I usually do is I just have a dedicated machine that I just use as a deployment client. Stepwise, what do we need to do? First thing, we need to have some hardware, which can be physical or virtual. And we need to have our deployment client. That deployment client could potentially also be the same client or the same server that we're running our Kubernetes cluster on, especially if you're running on Linux. For today's demo, we're assuming everything is running from a Windows deployment client that is nothing but a deployment client. On top of that hardware, we're going to need Kubernetes. And again, that can be managed Kubernetes like Azure Kubernetes Service or unmanaged Kubernetes like kubeadm. And we're going to take a look at both of them. And I'm going to provide you the scripts for both of them. And then on top of that Kubernetes, we will be deploying BDC. And to deploy a BDC, in the end, you're going to need two files, BDC.json, which will basically be your instance configuration, and control.json. That does more general things like which version, which CU am I going to deploy? Am I going to be deploying root containers or non-root containers? What kind of storage classes in Kubernetes am I going to use? And to prepare for all this today, what I did in advance, I set up a Windows VM, which we're going to see in a sec. And on that Windows VM, I was running one script, the one that I just told you about, that basically installs all my Windows tools. And this is a very lightweight client. It has 4 gigs of RAM, 2 cores. I deployed an Ubuntu VM with 32 gigs of RAM, 100 gigabytes of disk, and 16 cores. That's going to be my on-prem single node Kubernetes cluster. And on that, I also ran 2 scripts, one that actually does the install of AZ Data and my Kubernetes cluster itself. And I also pre-pulled the Docker images. By pre-pulling the Docker images, what do I mean by that? I said to you earlier that in a big data cluster, there's quite a bunch of pods and even more containers. These containers run based on images. So there is an image. Think of an image like an ISO file. And that image would, for example, be your Grafana dashboard. You can pre-pull them. Therefore, you already have the images cached. That means when you're actually deploying and installing your big data cluster, they don't need to be pulled. It's going to save us a little time later on in the demo process. If you skip that pre-pulling, they would automatically be pulled at the time of installation. And I also deployed a 2-node AKS cluster. So Azure Kubernetes Services, 2 nodes, 16 cores each, 32 gigs of RAM each. And to do that, I also ran a very quick PowerShell script. I could have done that through the portal as well. And the reason why one has the one node, why one has two nodes, I want to show you that no matter what kind of Kubernetes you're using in the background, your installation experience and processes and steps, they are exactly the same. And with that said, we're going to jump right into the demo, unless we do have any questions that we should address right away, Bob.
We do have just a software and updating question here. They're saying when,
Yes.
and I don't know if Azure Arc applies or not. They say when using SQL 2019 through Azure Arc, do we have to manage software updates for SQL Server /BDC, or is that then managed automatically by Microsoft?
Oh, okay. So BDC is not available through Azure Arc. So if you're using SQL Server through Azure Arc, at this point, there's only the so-called indirectly connected mode. So you would need to take care of updates. Once the directly connected mode, which has been announced, is there, we will probably get to a point where you would get the updates for that automatically, but that would only be for the services that are part of Arc, and that's at this point Postgres and SQL Managed Instance. BDC is not part of Arc, so you could not deploy that through Arc at this point.
Okay, excellent.
Cool. So I'm running my demos here out of Visual Studio Code. This is just one big PowerShell file that I will go through, and that's also in the demos. And you're going to see the link to those demos again also at the end of the slides. So first thing we're going to do, let's take a quick look at our, and let me zoom in a little bit for you here. I'm changing my context here in Kubernetes. So keep in mind, I deployed 2 Kubernetes clusters. So these 2 Kubernetes clusters, one is my BDC AKS, my Azure Kubernetes service, one is my local one. I can manage them both from the same machine. I can just switch context. A context is the combination of a user credential and an actual cluster in Kubernetes, and I got them both in the same config file. And if I take a look at this, what it will tell me, well, there's a couple of services running, and my Azure Kubernetes service, as expected, is running 2 nodes. So I got my VM1, my VM0 in there. They're running Kubernetes 1.17.13. Those are their internal IPs, and so on and so on. They've been up for 30 hours. So you can see I came well prepared and did this yesterday because I didn't want to risk anything. And if I take a look at my on-prem cluster and do a kubectl get nodes, I will see, okay, there's one single node in here, about the same uptime, slightly different version, being called BDC Linux. So that is also my Ubuntu machine that I have here on my same network. And kubectl, that will be super important also when monitoring deployments and stuff. kubectl, just like AZ Data and also Azure Data Studio, for those of you that were not aware, Azure Data Studio runs on Linux just as well as on a Mac, just as well on Linux. All we're doing here is completely cross-platform. So I could also say, hey, let's make a secure shell into my BDC Linux and do kubectl get nodes over there. Very same command, very same result. So no matter where you run those tools, no matter where you run these commands, if it's on a Mac, on Linux, or on Windows, they will be exactly the same. So if you say, well, Ben ran his demos off of his Windows, what do you need to do to get this done on Linux? It does the exact same thing. You can use the exact same commands. What we would usually do in a real-life scenario when doing this on Linux with kubedm, what we would usually do, we would join additional nodes because a cluster usually has more than one node. And also what I did is I provided just local storage. So every piece of data that I am storing in my big data cluster will be stored on local disk, kind of destroying that methodology where we usually separate storage and compute. For today, it's fine. Also, if you're trying to figure it out, that's completely fine. If you're thinking about doing that in production, obviously put some thought into what kind of storage are you running. There's a couple of great vendors at this event that know quite a lot about storage. And there's also another session today with my good friend Argenis, who's going to be talking about storage for SQL Server. So you maybe want to drop into that if storage is any of your concerns, and therefore have storage and compute really separated. Again, for today, we will leave it as it is. Let's take a quick look at the scripts that I have provided for you. And as you can see, they're all on GitHub. The first one, that's the one that is installing, and let me zoom in a bit for you. First of all, this will install Chocolatey. Chocolatey or Choco is a package manager for Windows, and it's just super easy. If it hasn't been installed before, it will just be installed by that one line of PowerShell up there. And then you can just go ahead and say, for example, hey, Choco install PuTTY. -y just means it's going to say yes to license agreement and stuff. Choco install 7-zip, Choco install Notepad++, and so on. And Choco will just go ahead and install all the tools that we've seen before. The only one that's missing is AZData, because AZData does not have a current Choco repository. Well, we just installed curl through Choco. So what we can do is curl, get that AZData file because it has a fixed link from Microsoft, and then just install it through MSIExec. Easy as that. So if you get a vanilla Windows installation that has nothing on it, open a PowerShell and run this script as it is, you're good to go. You got all the tools that you need. If you're going down the kubeadm path, and it's actually not a bad choice, what you could just do is go to the Azure portal and deploy a kubeadm Linux machine there. This is the script that you would need to run. Well, there's a couple of parameters in there that you may potentially want to change, but this script will get you completely set up. What it will do is it will get the certificate authority, so everything with Kubernetes will actually work. It will actually install Kubernetes. It will install the Docker tools. It will provide the local storage class. It will go ahead and install AZData, everything that we need to get ready. So while some stuff in there may not be quite production ready, it is a very easy script, and basically for you, you just download it and execute it, and you're good to go without putting too much thought into getting that Kubernetes configured. Again, if you're doing this in production, put a little more thought in your Kubernetes configuration, obviously. That's the easiest one. That's my pre-pull. I'm just providing a list of the images that I'm going to need and also which version. That's going to be CO8 here. And then I'm just looping through that. So for every image in that list, I'm going to pre-pull using the command docker pull and get that, again, just to save some time during the actual deployment. And last but not least, for AKS, it's 4 lines of code. If you get the Azure command line CLI, you log into Azure, you set, if you have multiple subscriptions, you do an account set and just set it to the right subscription. And then you say AKS create. This will create your Azure Kubernetes service. And in this case, I'm using a standard D8 SV3 with 2 nodes. Again, you may want to use a different size with more nodes or a different family depending on the compute power you node, and that's also available to you depending on which region you're deploying. And then I'm downloading the credentials of that cluster to be able to actually talk to it using kubectl. It's easy as that. And there's also the demos.ps, which is going to be the demo scripts that we're going to go through from now. So, while we're at it, let's just do one more thing. You've seen all these fancy demos with data virtualization and so, which is part of big data clusters. If you go to Azure Data Studio and go to the extensions tab, there is one extension called data virtualization. That's the one that you want to install. We're not going to be using it today, but that's the one that brings up all the fancy visits to run external tables from CSVs or from SQL Server, Oracle, Teradata, all that stuff that's so cool about big data clusters. So we were talking about control JSON and BDC JSON. Everything, just like in Kubernetes, in BDC, can be deployed through code. And to do that, we use control JSON and BDC JSON. So the general idea is you generate your configuration, and then based off that configuration, you do the deployment. And if you don't have a configuration yet, you can just create it by doing AZData, BDC config init, and we'll be providing a source. And that source, there's just a couple of different profiles. And we're going to see that in Azure Data Studio in a sec, a little more plastic. And the only other thing that we're providing is a target path. So this will go to a folder called kubeadm-custom, and the -f will just overwrite this folder if it already exists. So let's fire that up. And what this will do is, based on a set of preset settings of where AZData or Microsoft thinks, well, these are probably the best settings for a dev test environment of kubeadm, it will generate those 2 files for us. Let's take a look at them in Notepad. So let's start with the control one. In here, first thing, we're going to have a name for our cluster. Think of that like a named instance. You can have multiple big data clusters running on the very same Kubernetes cluster. Here's my image tag. If I want to install CO6 instead, I just change that here. If I want to do CO7, that's all I do. Don't do CO7. One thing that I would need to provide when doing this on a kubeadm, I would need to provide storage classes. And we're going to see that later on when we actually deploy that on Linux. And then there's also stuff like what's my controller port, what's my proxy port. And here, for example, in the security part, that's where I would add something like, hey, please do run as root containers, because some features actually require containers to be run as root. But since CF5, by default, everything runs as non-root containers, following the principle of least privileges. And then we get the BDC JSON, and BDC JSON will tell me, okay, so we're going to have one name node, we're going to have one Spark head, we're not going to have a zookeeper, we're going to have one master instance, so this will not be high availability. We're going to have one replica in the compute pool. We're going to have 2 replicas here in the data pool. We're going to have 2 replicas also in the storage pool, and we're going to have Spark run off our storage pool as well. They can be separated or they can be combined depending on your workloads. And so this is really how I'm in the end going to have my resources allocated. Be careful here and think wisely and choose wisely, because at this point there is no up or downsizing of an existing instance. If you decide to have 2 replicas within your data pool, that's cool, but you cannot change that. You would need to redeploy. I mean, you could obviously back up and restore your data back into that, but you would still have potentially, depending on the size of your cluster, some significant downtime. So there is no switch as for an Azure service where you could just upscale or downscale that deployment. So think in advance how much replicas of every given service you're going to need. If you want to do this in a wizard, hey, there we go. And we're not going to update Azure Data Studio now. I think that's probably not a great idea. If you're in Azure Data Studio, in the connections pane, down there, by default, in any of the latest Azure Data Studio releases, you're going to have SQL Server Big Data Clusters. And right next to it, there is a plus, which is called Create New Controller. And that is what Bob was talking about. If you fire that up, it will give me the option to deploy a brand new SQL Server Big Data Cluster. First of all, accept the license agreement. This will also, again, check if you're running all the correct prerequisites. Can you pick your version? It's only available in 2019, so that's an easy choice. And then it's going to ask you, what's going to be your target? And you can either use a new Azure Kubernetes service, which would also take care of the deployment of the Kubernetes service for you, or you can deploy into an existing AKS, existing kubeadm, existing OpenShift cluster, or an existing Azure OpenShift cluster. I will just go through the first wizard to start with. But we're not actually going to be deploying a new AKS because I already did that, but I want to show you the full deployment experience here. And what that wizard does is, you see AKS dev test, AKS dev test, HA. Those would be the sources that you would be providing to AZ data. So if I do AZ data BDC config init -- source AKS dev test, that would be the profile that I'm getting. And down here, you would see, well, if you do dev test, you're going to end up with 1 SQL Server master, 1 compute replica, 2 data replicas, 2 HDFS and Spark replicas. In HA, you're going to have 3 masters, and so on and so on. This will give you the storage settings for the service and also which features are enabled. Am I using Active Directory authentication, or am I using basic authentication? Is this highly available, and so on and so on. Since this is also creating that new AKS cluster for us, we would need to provide a subscription ID here. I'll just put anything in. It's going to ask me for a resource group name, for a location. So again, choose the location that makes sense to you, because if you're talking to that cluster, you may have latency depending on where you are actually located. What's your name for your cluster? That's the one that was just called MS SQL cluster in the previous one. And again, how many VMs do I want to have in the background, and what's my VM size? That's the one where I had 2 in my script. Say next, provide a password. For the basic authentication, we're not going to do Active Directory. And then again, you could still change all these settings. So even if the preset says, well, we're going to have 2 data pool instances, there's nothing stopping me to changing that just to 4, for example. I could still separate Spark and storage pool if I need to. And once you're done with all that, it's going to give me a little overview. I can script this to a notebook. And if I would go ahead and run this notebook would actually do the creation of my, let's scroll down. It would do the creation of my resource group. It would create my AKS cluster. It would get the credentials just as in the script that I've shown you earlier. And after that, it will call AZData to deploy the cluster. Since we already have a cluster, let's do this and close that and go for a slightly shorter version of that thing, because we're going to do an existing Azure Kubernetes Service cluster. We're still going to be using the same profile. So we're still going to be using DevTest just to reduce the number of nodes in here. We're going to do this in our BDC AKS admin. So we're going to be deploying to AKS. Again, providing our password here. Leaving all these at the defaults, scripted to a notebook. Then we pray to the demo gods, and then we say run all. And what this is going to do, this will kick off a deployment of a big data cluster for us. That's the experience that Bob was describing. We're already at the point where it does AZData BDC create, pointing it to a custom profile. And depending on your machine, depending on the size, and also depending if you've pre-pulled the images, which I did on the Linux machine and I did not do here, this will take anywhere from 10 minutes to multiple hours. So if this takes a while, don't worry. It will usually, especially if you've already pre-pulled the images, it should come back after 15 to, let's say, 30 minutes, again, depending on your machine size and performance. But yeah, give it a little time, be a little patient. We're just going to keep that running in the background. And
so if I jump in here with a few questions, Ben?
Of course.
All right. Going back to earlier, you were discussing, you pointed out Zookeeper really quickly. Someone asks, could we use Zookeeper instances installed by BDC for other big data technologies, for instance, Apache Kafka, or would it be better to spin up separate Zookeeper instances for non-BDC needs?
Oh, well, I'm a consultant, so I'm going to go with it depends, but let me elaborate a little more on that. First of all, yes, you can. Just like you can use the HDFS, for example, as your regular enterprise HDFS. So in theory, you could deploy a big data cluster and just use it as a file server. You could do that. The thing that you need to consider is how much manageability do you need? Because obviously the components that are inside big data cluster, they are tuned to work with big data cluster. So there may be restrictions depending on your workload where I would opt against it. So I would need to know a little more about what you're exactly planning. But generally speaking, all these are full-grown, quote unquote, regular components. So you could use them independent of the BDC or just basically use parts of the BDC if you feel like that.
Okay, cool. And one more here. They're just asking for clarification on replica settings. They go, is the number of replicas fixed at time of deploy for all replicas? For example, I cannot auto scale additional compute nodes if necessary, or is that just for data replicas? Because if they are added or removed, then the data would need to be moved around as well.
No, that is true for every single node at this point. Honestly, for the compute pool, for the compute nodes, it doesn't necessarily make that much of a difference because they don't store any data or anything. And as long as they're not doing anything, they also don't eat any resources. What you could do at any time is upscale or downscale your Kubernetes cluster. What you cannot do is upscale or downscale the number of worker nodes, and that is true for every single pod and pool at this point. So you could not change that.
All right. Thank you very much.
Cool. So I'm switching my context back to my BDC AKS admin. And the first command I'm going to run is kubectl get namespace. And what we see here is MS SQL cluster. There is a new namespace. For those of you that haven't worked too much with Kubernetes so far, Kubernetes is organized in many ways. And one of them, or the most important one in my perspective when it comes to organizing a Kubernetes cluster, are namespaces. Think of it like a folder, maybe. It's a logical grouping, so you can have pods with the same name, for example, across multiple namespaces, but not in the same namespace. And the one that we're creating here is called MS SQL Cluster. I could have also called it Benz Pass BDC or anything, just as long as it's unique. And that also helps me, especially if there's multiple different applications running on that cluster. That will be super helpful when it comes to actually looking what's happening in there, because what I can do now is kubectl get pods in that namespace, and instead of potentially getting 150,000 pods running in all the other applications, I only get those that I care about. And what we see here is, well, we started with the control, and that's 3 minutes, 51 seconds old at this point. And the control is the first one to start, and this one will then spin up all the other components one after one. If you really want to follow that, there's a super interesting switch --watch. And if I do this will just keep waiting for that process. So whenever anything changes during my deployment, if there's new pods being deployed, if there's new pods being added, because over time we will see more pods, or if just the status of an existing pod changes, like for example, my logsdb changes from init to running, for example, or to pending, or to or whatever the next status may be, I would see that here. So that would also help me see, there we go. My management proxy just went from 1 to 2 of them ready. So we would see the next step, the next component being deployed shortly after that. And again, this will take a bit longer if we do not pre-pull the images, which I did not do here, because usually pulling images in AKS is rather quick, because, well, obviously you're pulling data from Azure to Azure, which, unless the demo gods are not on your side, this shouldn't be that big of a deal. Let's cancel this query. And like I said, we can do this cross-platform. So I could also do the very same thing running from Linux, but on Linux, I'm going to do it using the command line instead of using Azure Data Studio, even though I could use Azure Data Studio on Linux as well. So let's also open a PuTTY session here so we can follow along, because one of the I highly recommend you do them, if you do this at home, do them one after one. One slight restriction that you have is you cannot be in 2 Kubernetes contexts at the very same time. So if you're deploying to 2 different clusters, to 2 different Kubernetes clusters at the same time, you could not monitor them easily unless you provide a whole bunch of switches to your kubectl commands. So, and what we're going to do here is kubectl get nodes in our MS SQL cluster namespace. And not get nodes. Hang on. Get pods. I was wondering, why is there something in there? And it tells me, well, there is no MS SQL cluster namespace. And that is because we haven't deployed one yet. Still, if I say --watch here again, look at this. This will run. So this will just keep monitoring if anything ever happens in my MS SQL cluster namespace. And we will make something happen here. So what we're going to do is, let's open a secure shell here. And first of all, we're going to run the very same command that we ran earlier. azdata bdc config init kubeadm dev test with kubeadm custom and the -4 switch. There we go. And I'm going to do 2 changes to this configuration before we kick this off. First of all, I'm going to use a text editor because in the end, it does not matter which path. So I could do this here in VI because I want to deploy CO6 actually instead of CO8. So that's done. I saved that. I could also change that using azdata. So azdata has a command, azdata bdc config replace. And in this file, it would change my storage class for data to local storage. And I could do the very same thing for logs as well. Let me just do this. This will set those parameters for me. So especially if you're scripting this and you're still creating the JSON file from scratch, if you're not reusing just the same JSON file every single time, that's a super easy way of doing that. If I go back to my file, you see my class names are now set because of that command name that I ran earlier. And with that, I can say azdata bdc create kubeadm custom. This will look at this configuration and will kick off the configuration process. There's a couple of environment variables that you can set. Accept license agreement, azdata username, azdata password. I did not set those, so it's going to prompt me for that. Yes, I do accept the License terms, I'm going to use admin as my username. You can use pretty much everything except SA. Going to be providing my password. And since they match, it's now starting my cluster deployment. If we look back here, ooh, there we go. My control DB is already up and running. My control as well. And we're going to see the other ones coming up shortly, one by one after that. Let me do this. I just open another PowerShell here. And I'm going to zoom into that for you in a sec. So this is the one that we kicked off on the AKS earlier. So we see this one has already progressed quite a bit. So we have our application proxy running, we got the compute running, we got a couple of them are container creating. So you see some of them he can do in parallel, like for example, here our data pool. Our data pool has 2 nodes, 2 replicas. That's where we got minus data 0 and 0, 1 and 0, 1. And same thing for the storage pool. We only had 1 instance of the compute pool, so there's only 1 of those. And this will just keep going until it's done deploying all the different endpoints. Bob, while we're at this, do we have any additional questions at this point?
No more have come in since the last time I asked you any, so we're actually doing quite well. But if I could throw a quick program note in here.
Yes, please.
For people, sorry, just thinking what to say. Those of you watching, if you may have noticed random QR codes appearing in sessions, there is a reason for that. Check them out. QR codes are available in random sessions dispersed throughout the conference, as well as some exhibitors' booths.
Can I win something?
I hope so. I don't know. I assume that's what it's related to.
Yeah. How mean would it be if they would just be providing those QR codes and then in the end there's nothing behind it? Well,
that would be not nice, but no.
It would also be funny in a way. So
that too.
But well, then again, I'm a horrible person, so we should also keep that in mind. This one here is still running on the Linux machine. What has already happened is my cluster controller endpoint is already available. My cluster controller plane is ready. So it tells me, well, if you remember that picture that we saw earlier, the orange controller on the left, that's the one that is now already and really taking care that all the others are being hooked up together so they work together. Also, I already see my cluster's endpoint here, 192.168.1.4. So we can clearly see this is an on-premises IP address and we did not change the default port. So we got port 30080. This would also be the port that I could later on use to manage this cluster. This would also be the IP that I could use to manage this cluster, either through AZ Data or through Azure Data Studio. If you connect to it at this point, it's always a little hit and miss actually in Azure Data Studio if it will do something. It's always a safe bet to wait until the deployment is done, because, well, depending on its state, it may be answering that query or not. So Azure Data Studio might get confused with that still. That's going to be the endpoint that we're going to be using later on in Azure Data Studio or using AZ Data. While this is running, let's talk about a couple more advanced things, even though we've already mentioned them briefly. One thing that I regularly see out in the field is running Spark as a separate pool. As you've seen, by default, this is being deployed as part of your storage pool. And that may be a fair assumption if you're really coming from traditional SQL workloads. But if you're making full use of the beauty of BDC, and part of the beauty of BDC are the built-in HDFS, but not just the built-in HDFS, but also what you can do with it and the Spark endpoints in there, you will potentially very quickly come to a point where you may do very heavy lifting workloads using Spark. And heavy lifting usually warrants having dedicated resources for that. Active Directory integration. We saw it a couple of times today. I did not go through it because I did not jump through the hoops of having an Active Directory actually for my demo. Before deploying a big data cluster into an Active Directory, there's a couple of things that you need to go through. and I'm going to provide you the link to that later on. There's just, you need to have an org unit for it. You need to provide a couple of service accounts and a couple of permissions before that actually works. Another thing, at this point, like I said, I'm doing all on local storage. Out there in the wild, you would usually have different storage classes because for logs, and be careful there because the storage class, the kind of storage being used for logs, that's not your SQL Server logs. So it's not like, oh, I have my log files on a different drive. Then that's not the thing. We're talking about the Kubernetes logs here. So you probably do not need this to be on any very high performing storage, whereas for your actual data and the data logs, that might be a different story. And root versus non-root containers. I've also briefly touched that before, especially if you're doing a lot in Spark. There's a couple of things in Spark, like, for example, bringing in new modules or like Python modules within your code and deploying them as you go from your notebooks or your code. This requires root containers at this point. So again, they're not being deployed as root containers by default. You may want to consider that for your specific deployment. And there's quite a bunch more, but these are the most important ones. So let's jump back here and we can see, okay, our data pool is ready, our storage pool is ready. How are we doing over here? This one is almost done. Let's take a quick look if we can already connect to this endpoint in ADS. Back in ADS, where this is, by the way, still running. And that's another thing to be aware of on my deployment over here in VS Code, where I'm just running this out of PowerShell, or actually in this case, out of the bash from Linux. You will immediately see the output of that tool. Whereas in Azure Data Studio, you won't. You will get the starting point here, which starts executing. After that, you will not get any response until it's actually done, which is why it's so super important to monitor that through kubectl, because you may still be in a situation where that deployment just doesn't work. One typical trap, I should say, if you do this on kubeadm, for example, by default, a kubeadm VM or a Linux VM on Azure comes with, I think it's 60 gig of disk, or might even be a little less than that. You need about 100 gigs to even have enough space to actually download all those containers. So if you do a default deployment of a Ubuntu machine on the Azure portal or on Azure, and do not upsize your system disk afterwards, there's nothing you need to do in Ubuntu after that. All you need to do is just change the disk size in the portal or using PowerShell, and you're done. Still, if you do not do that, you will end up in an endless loop with Docker constantly trying to pull one image, and then it realizes, oh, no, the other one is gone, and then it keeps doing this and flipping back and forth. Learned this the rather hard way. Still, back here in SQL Server Big Data Clusters part of Azure Data Studio, instead of just creating a new controller, I can also connect to an existing controller. And what I can do here is I provide the URL. Authentication type could either be basic or Active Directory integrated. And then we say admin and provide our super secure password. And let's see. See, there we go. We're already in a state where it responds, and we already see all the endpoints of this specific cluster. Now, in my case, and what we also see is 2 of our services are not there yet. Still, we know what the endpoints are going to be. This is especially important if you're doing a deployment towards a multi-node cluster, or if you're doing an AKS, because you would. In my case, it's easy. I'm doing this on a single node cluster. That single node has only one single IP. Well, what's the big guess? Of course, this is going to be the IP that I'm going to be reaching it. If you do something like dynamic IPs in Azure, those IPs will change with every single deployment. By the way, what I tend to do is I add those IP to my hosts file in Windows, so I can basically still reach them using the same name, even if I do redeployments, because then I don't have to change any of my code. In here, I can keep refreshing that, but I would not see anything that I would not get to see up here. And there we go. Cluster MS SQL cluster deployed successfully. Let's get out of here. And this guy here also seems, there we go. This one is also, that's perfect timing. And again, this will also show me the endpoints for this cluster. So we now got one cluster in AKS deployed and one cluster to our local machine. And we see, well, they took equally long. The AKS took a little longer because we didn't pre-pull there, but again, it's natively in Azure, so that helps a bit with that. So let's change our context back to our kubeadm cluster and log into our cluster. And logging in means I just also change my AZ data context to this specific cluster, my namespace, MS SQL cluster, my username is admin, and my password. And again, if this would be an environment variable, let's try that again. There we go. I'm now logged in, and now I could say, hey, AZ data, I want to get my endpoints for that deployment. Oh, and by the way, by default, this will be JSON. Nobody likes JSON unless for potentially coding purposes. So I could also say AZ data BDC endpoint list and output it as a table. And I would get the exact same result that I would get from Azure Data Studio, which kind of gets me back to the point where I said earlier, well, you don't really need Azure Data Studio, but still, it's kind of more human readable and easier to have it right here, especially with clickable links, because when I want to go to my Grafana dashboard now and see what's going on in my cluster, well, all I can do is just click here, and this will bring up my dashboard, which is warning me that, well, we have not deployed any certificates yet. So there we go. And the same thing we could do for the Kibana dashboard and so on. If I go here and run a little command against that big data cluster, we'll see, okay, we are running CO6. And that makes sense because what we did earlier is we changed the configuration file to actually run on CO6. We changed that in the control JSON. If we just go back here and take a quick look at this endpoint. Let's just grab that IP and port from our AKS cluster, run the same command. This one's running CU8 because we did not change it. And by default, your control JSON will pick up the latest CU that your AZ data is aware of. So before you can actually upgrade to a new version of BDC, you would need to upgrade your AZ data version. You can always deploy an older version. You cannot deploy anything newer than that. And if we were going to go ahead and upgrade my big data cluster, the one on premises, the one running in kubeadm, there's another super simple command, AZ data BDC upgrade. My MS SQL cluster, the name of my cluster. This is the image that I'm going to, and this is the registry I'm going to get it from. And there's a slight spoiler alert here. If I do this, this will now go ahead and upgrade my control plane. Let me just kill this and this will take one node down at a time and bring them up once again. Let's see, by the way, we already had an error here. This will usually take, even for the simplest of clusters, about 30 minutes. So we will probably not get to see the result of that at the end still. If we did, what we would see here is, if you run that query again, it would be on CO8. Your cluster will be reachable and available during the upgrade for most of the time, except for the part where the master instance isn't ready. So that may be kind of misleading because in some cases you would actually be able to reach your cluster, but even though you can actually reach it, it may not be doing the right things because potentially at this point you're just updating your storage pool, and that means your storage pool is unavailable. So if you're running a query against an external table that sits on the storage pool, that may go wrong. So yeah. And again, upgrading only works version-wise, going from CO6 to CO7 to CO8 or even the other direction, not a problem. What you cannot do is do this to upgrade any of your configuration files. If you figure out that, well, I did a mistake during my deployment, I didn't want to have 2 but 4 nodes in my data pool, well, then you go ahead and redeploy that. Sorry for that. If we take a quick look here, okay, they're slowly all coming back. It starts with control DB and it really goes through it one by one. So an upgrade always takes longer than a full redeploy, because as we've seen when we did the full deployment, It was, for example, deploying the storage pool containers in parallel at the same time. Now that there's data and everything attached to it, it needs to do this a little more cautious, so it really does them one by one. With that, before we get to potentially more questions, I got a couple of resources for you. If you go to bookmark.ws/passbdc deploy again, that's going to be all the code that we had today. If you just go to /bdc code, it will take you to another repository on my GitHub. We'll just get a couple of demos that you might be interested in running. If you go to bookmark.ws/bdc course, it will take you to my Pluralsight course. If you go to bookmark.ws/bdc book, it will take you to the book that I wrote with my friend Enrico, and that my good friend Mohammed was friendly enough to edit for us. We will get back to that upgrade, but before I forget about that, please do make sure to provide session evaluations. It is super important for the end and also super important for us speakers. As you probably know, especially at events like the PASS Summit, we usually try brand new sessions because we want to have brand new content for you, especially in stuff like this where we have this learning path. So please let us know, or in this case, let me know what went good or what went potentially not so good. And having that said, do we have any more questions for the moment?
We have at least two that have come in so far. So one of them is, once the BDC cluster has been deployed, is there any procedure to shut it down or restart?
Well, first of all, yes and no. So it kind of depends on where you're deploying. Basically, what you would do if you really want to shut it down is you would just shut down your Kubernetes cluster, or because Kubernetes is kind of the layer, well, not just kind of, Kubernetes is the layer that everything is running in. So you would either shut off, especially if you're in AKS, please do make sure if you're not using your cluster to either delete it or to at least shut it down, because otherwise you will be charged for it. If you're not going to be using it for a longer time, make sure to delete it, because otherwise you will still be charged for storage. But there is no way to basically stop just the application. I mean, there would be ways behind the scenes of doing that, like connecting into every single container and killing some processes, but that would be very undocumented and also very unrecommended, if that makes sense. So you would not stop the application. You would potentially rather stop the cluster. If it's on a Linux VM, just shut down the VM. If it's on bare metal, just either shut down the Kubernetes service or really shut down the bare metal server. If it's on AKS, make sure not to just stop, but deallocate the VM scaling set behind it. Because if you're deploying an Azure Kubernetes service, basically what it does is it deploys a so-called scaling set. So that means the number of VMs that we've defined, it will deploy the VMs and then just get them into that clustered set. You can stop it like any VM in Azure, but you need to deallocate it to make sure you're not being charged for it anymore.
Nice. Okay, question number 2.
And who likes being charged for stuff that you're not using? I mean, seriously.
Not a fan.
Who came up with that?
So Marius is asking, how do you integrate your SQL Server 2019s with the BDC after the deployment? I'm not exactly sure what they mean by that.
Okay, I'm going to guess, and if my guess is wrong, if you could just come around and ask a little more specific. But your big data cluster already is a SQL Server 2019. Let me just do this and go back a couple of slides here. All the way up here. There we go. Your main entry point into your BDC, that's your SQL Server master. Your SQL Server master is a full-grown SQL Server 2019, with the only difference being that it's running on Linux. Your SQL Server master, you can go ahead and create databases there. You know what? Why am I showing you this with a slide? I mean, I just deployed a big data cluster, haven't I? Why don't we just use that? So there's my big data cluster, and by default, it will run on endpoint 301433. So 1433 being the SQL Server standard port, and it's just adding a 3 to that. That's also something you could change in the configuration. What I can do now here is say, I could either restore a database in here, or I can say, hey, you know what, let's run a new query. Create database. I love BDC. There we go. And Bob, please don't tell me about all the comments that you're going to get now that I did not provide proper locations and I did not provide proper recovery mode and everything. I know this is so wrong what I just did. It's the select star of create database. But my point being, there we go. This is my database. This is a full-grown SQL Server 2019. So even if you say, well, I'm not quite sure yet when and how I'm going to use the BDC components, but I want to upgrade to 2019, especially if you run an older version of SQL Server where there's no direct upgrade path anyway. Not that there's still people out there that are running SQL Server 2005 or something like that, but I know there are. I know you. Go for it. Deploy a BDC, use it as your regular SQL Server, and then start using those other components whenever you feel like you're ready for that. No problem with that at all. It comes with the restrictions, obviously, that any SQL on Linux will have. So you will not have generic ODBC, and there's a couple of more. They're almost on feature parity, but not exactly. There's a nice overview on the docs that will show you exactly what can be done and what cannot be done on a SQL on Linux. Still, other than that, they completely integrate the same way. So you could now start creating objects like linked servers, external. Nobody uses linked servers anymore. We all use Polybase, but all that would be available here. Or you could just access this endpoint using whichever tool you would want it to access. You could point your application directly to it, or you could just say, well, I'm only using BDC for like analytical workload. So you use integration services to push data in there. And then you're going to have processes in place that will push data to the storage pool, that will push data to the data pool. Or you come the other way around, just push data directly into your storage pool and then start consuming that data using those external tables. And that's probably a process that's just going to take a while if you're coming from a traditional SQL environment, because obviously it's going to require a couple of code changes if you're switching from a just traditional SQL tables to external tables and potentially having data that doesn't even reside at all anymore in SQL tables, but only resides in stuff like Parquet files. Because I've seen quite a couple of instances where querying a Parquet file was just as fast or even faster than querying a SQL table. Hope that makes sense.
Totally. All right, and this one's I'll call it a metadata related question here. Can we edit the endpoint lists to add links to other web pages? It would be nice to use the endpoint list to have a single place to summarize all my company's management links.
I would not be aware of any way, and if there is a way, it's highly undocumented. So I would actually do it the other way. Let me go back.
Yeah, I'd almost say get a list of the endpoints and modify it elsewhere and display something like that.
Yeah, I mean that's the thing. What you can do obviously is can I just where do I do this here? And there we go. Make this a little more readable for y'all. If I do this and say AZ data, and of course I'm going to type this BDC endpoint list. Again, by default, this will be a JSON format. What I would rather do is take this, because you may end up with having multiple BDCs. You may end up with having BDC and ARC and all kinds of endpoints that can be fed from AZ data. I would go ahead and take this, and I mean, this is JSON. You could just take it and pipe it through PowerShell and save it directly to a table in SQL Server. But don't start messing or modifying that list as it comes out of AZ data, but rather use that feed and collect it somewhere else, potentially in your SQL Server that you already have here. I mean, it's not a lot of data, but well, I haven't thought about if it's even possible. Like I said, I wouldn't even try jumping through these hoops.
Sounds like a lot of work to me.
And by the way, as we can see here, our upgrade is nicely progressing. So we're currently at the point where, and you can see, it does the metrics, it does the management proxy, it does the gateway, now it's at the app proxy, and so on. And it does really one service at a time in this upgrade process, which is why it's taking longer. Cool.
Nice.
Anything else?
I got one more that's come in since then. If you have a data warehouse and they say using Data Vault, hint, cache
Yay!
calculation each time, on SQL 2016, approximately 5 terabytes, would you migrate all of that into a BDC or initially just use it as an external data source?
Whoa. To start with, I would. So, one interesting thing about Data Vault is also from a Data Vault perspective, I would lean towards pushing it into the BDC because some components of BDC, especially the data pool, they're kind of made for Data Vault. Because, for example, the data pool, it does not support updates. It does not support deletes. It only supports inserts and truncates. The only command that you will have in a Data Vault is an insert command with a couple of exceptions. But especially for your larger tables, for larger satellites and stuff. So I would be leaning to push that into the BDC as it is. Still, that's again the beauty, especially the beauty of how Polybase and external tables work. You could start having it as external tables. The only issue that you were going to have with the Data Vault is that you could not easily migrate it step by step because you're probably going to have foreign key restrictions in there, depending on how you've actually laid that out on the physical layer. That's the only thing that I would be kind of hesitant about, because otherwise you could say, well, I start by just bringing in a couple of hubs and a couple of satellites, but not all of them as external tables, and a couple I will already fully migrate. And then you go step by step because you could have an external table that is called hub.customers. And at this point, it's an external table pointing to your other SQL server using Polybase. And at some point, all you do is you drop that external table and recreate it, but this time it's an external table pointing to your data pool or your storage pool. And all your queries will keep working. That's kind of the beauty of BDC, because unlike linked servers, where your whole query will change if only the slightest thing will change on your source table or on your connection, with external tables, your queries never change again, unless obviously you're changing data types and data sources completely. If you're querying a column that just doesn't exist anymore, your query should probably change. But in the regular cases, quote unquote, that would be a perfect instance. So if you have not set up your Data Vault using foreign key constraints, you could do that step by step.
Okay, questions keep coming in here. People have some good ones. And this is a please correct my understanding question if it is wrong. They say, if I have 4 classic SQL 2019 servers, a BDC server will come in as a new server in addition to those ones. And then they further up say, can you push predicates from a classic server to a BDC server?
If you do that as a Polybase connection, yes, you can, because Polybase by default will push predicates as much as it can, and obviously between SQL servers, even between SQL servers that are on the same version, that works like a charm. Yes.
Okay. License question coming up.
I love license questions.
Yeah. Does scaling the storage pool require you to buy more licenses, or can it be scaled freely?
Yes. And I do understand that this was an either-or question.
Okay.
So, big data clusters come with Standard Edition and Enterprise Edition of SQL Server 2019. And the difference between Standard and Enterprise is the number of node cores that you're getting. If you're in Standard Edition, you have to be on core licensing, though. So for every core that you license your SQL Server with, let me jump back to this. So let's say you have a Enterprise Edition with 8 cores. You're going to get 8 cores here in your master instance. And then on Standard Edition, it's 1. And on Enterprise Edition, I'm leaning to saying it's 4. Bob, do you remember the answer I gave 2 days ago to the very same question?
I believe it was 8. I want to say you said you thought it was 4, and it ended up being...
Well, it is in the licensing guide. And if you send me a tweet or email, I'm happy to send that to you. You get a multiple of the course that you got on the Masters. So let's just go with 8, and don't quote me on the 8 if the 8 is actually a 4. But if you got 8 cores here, you would get 8 times those for cores here on the right side to distribute across your pools. So depending on your workloads, you may get them for free or you may need additional ones. But what you can do, instead of buying additional cores on your master if you don't need them, you could actually also license additional core nodes. And those would not come as perpetual licenses, but those would be an annual fee. And I completely forgot how much they were. But they're compared to what you're getting out of them, they're super cheap, actually.
Cool.
Yeah, it's in the licensing guide on like page 14 or so. But again, ping me, and I'm happy to show you the link for that.
Excellent. No other questions at the moment.
Cool. So let's see if our upgrade has actually proceeded. Well, it has not, and that was kind of expected. Yeah, we're at storage pool part 1. And I really have to take care of all these light modes here because I keep clicking into the wrong window. So with that said, if there's no more questions, thank you very much again, Bob, for your help today. That was awesome. Thank you very much, everyone, for joining me today for this session. I hope it was valuable to you. Again, please do provide some feedback. I'm going to put my contact details up here again and not block them. Please do provide the session feedback. Let me know if anything in the demos isn't working for you as it should. If you're trying this at home, if there's anything I can be of assistance with, let me know. Thank you so much for supporting PASS by coming to this virtual summit. And I really do hope to get to see all of you again in person, even if it might be a slightly smaller event next year. Thank you so much. Thanks again, Bob. Thanks again also, Eric, for getting up at this ungodly hour. And I hope to see you around. And with those extra 3 minutes you just got from me, you got an extra 3 minutes to go to the expo hall and see some of the exhibitors there. Thank you.